Hey, can you hear me?
I can.
Okay. All right. So, um, I'm gonna do some screen sharing. This laptop I'm using is a little slow, so bear with me. Um, we'll share the screen and some photos. Okay. Um, so what I'm gonna do is just go through the real quick definitions of oh, these. This is not what I wanted. Um, how do I get out of here? I want, where are the photos I had open? Bear with me, guys. This is an unfamiliar PC. Here we go. Here we go. Okay. All right, so we'll start. So I'm gonna just talk you guys through uh, just kind of what the definitions of the terms are so that you can understand them. And then I want you to ask me questions. Okay? Does that sound fair? Hello?
Sounds great.
Okay. All right. Let me make this bigger over here. So I don't know. Okay, so with um, we'll start with the definitions. So spatial resolution and contrast resolution. Those are the terms that we typically that we use. But I need you to be clear that high contrast resolution and spatial resolution are the same thing, right? Now, Savannah, I know we've had some discussions about this, but Leah, if this isn't clear, then just make sure you chime in, okay? Um, okay, so high contrast resolution or spatial resolution is one thing, and then low contrast resolution. If we talk about that, we're saying just contrast resolution. So those are the same things, all right? So just make sure it's clear. And we're going to use the term spatial and then just contrast resolution, okay? So when we talk about spatial resolution, what we're really talking about is if you look on this image here, I'll zoom in a little. If you look on this image, um, we're talking about the size of the pixel. Or if you look at this top one, the size of the voxel, right? The smaller that is, the higher the spatial resolution, period, right? Um, so that's what we're going for. Spatial resolution is the ability to resolve or to see tiny structures. The smaller the structure that we can visualize, the higher the spatial resolution. And so what goes into that, right? That's what we want to know. So one is the matrix size. So if you look at the image again, and this matrix laying on top of this little circle, that's the matrix. The higher the matrix, the smaller the pixels, right? The more boxes we have, the higher our spatial resolution. But that's in plane, right? So that is in, if you look at my cursor, in the X and the Y direction. Okay, so that's like the image we see. So in that direction, that's called in plane resolution. Now, if you look here where it says Z, Z is essentially synonymous with the slice thickness, right? It's the Z direction, which is head to foot. So look at this here. This is our Z direction, okay? Head to foot. That's our slice thickness. So that also has a type of resolution, and that's called longitudinal resolution, okay? Or lengthwise resolution, right? The Z axis represents that. So when we go back to that question that was like on the worksheet, and we think about the effect of slice thickness on spatial resolution, then we can say, okay, the thicker Z is, the lower my spatial resolution. Okay, so they are indirectly proportional to a degree, right? So again, we look at Z here. We see that if this was, hold on, you know, I got another picture for you. Oh, what just happened? Don't do that. All right, here's another picture. So, well, I'll finish with Z. So, does it make sense, I guess? Let me ask you, does that make sense that the bigger the slice, the lower the spatial resolution in that direction? Just like this picture represents the matrix here. The more dense the matrix, the higher the spatial resolution. Is that part clear for you guys or no?
Yeah.
I'm still confused on why it's the lower contrast resolution when the slice gets bigger.
Okay, that's so we're talking about spatial right now. Are you clear on spatial?
Yeah.
Okay, so let me go over to the, I won't even cover this slide then. All right, so let's talk about this first, okay? Because contrast resolution or low contrast resolution really, it's just about being able to see what's on the image clearly. That's all it's about, right? Low contrast resolution is saying I can tell the difference between subtle densities, right? So this is so dense and this thing next to it's so dense, and I can visualize the difference. That's our contrast resolution. So some of that's subjective to the individual, right? But we can still get an understanding of what it is. So if we look at this image here, this is a phantom scan to determine the contrast resolution. Okay, so they put in these items within this phantom that vary very little from water. And then they scan a slice of it. And they say, okay, if you can observe these, each of these subtle differences, then we have an adequate contrast resolution to be able to see. Does that make sense?
Makes sense.
Okay, so that's fundamental right there. Okay, so now let's look at this next picture here. Okay, one of the components of low contrast resolution are two components. One is signal to noise ratio, and the other is like noise, right? So we have signal and noise, I guess is what I'm trying to say. So if you look at this image I have pulled up here, the image on the left is very noisy. Do you guys see that? How it's just really like grainy and mottled. Do you see it?
Yeah.
Yeah.
Okay. And then the one on the right is it's very clear. It's easy to distinguish these things, right? So same holds true. Why does it keep doing that? I don't understand what I'm doing here. That's not what I want. This is the image I want. Why did it? Okay. Why is it? There we go. Okay. So check this out. So if we look here, we have this like with a real image now, a real slice of the abdomen. We have image noise, like it's incredibly noisy here. And then we have a clearer image here, all right? So what I want you guys to understand is the difference here is going to be technical factors. And I'll connect the dots to slice thickness in a sec, but so the image on the right on this picture has a higher technique. They're using more mass on the right. And more mass equals more what?
Like more photons.
Exactly. So more mass means more photons, which also means more signal. Okay? More photons equals more signal. More signal means a clearer image or a higher contrast resolution because we're getting more information. You could think of the photons as literally as more information, right? Because they pass through the person. Some are attenuated, And the more that pass through, the more data those detectors are getting about what was scanned. More photons mean more signal or more information. That's how you need to think of that, okay? Are we good there? So for the final step on low contrast resolution, the dots you need to connect is this with slice thickness is the, I'm going to stop this screen share. Well, you know what? I quit. All right. How do I stop the screen share? Right here. Okay. So the dot to connect is the thicker the slice, the more photons. Therefore, the more photons, the higher the contrast resolution. See what I mean? The thinner the slice, if the technique stays the same, if we don't change any technical factors except for the slice thickness, then we have less photons in that slice. So we have a lower signal and a noisier image. Does that make sense?
So when the slice is thicker, it gets more photons, so then it has better contrast resolution.
Right. Right. There's more photons, so there's more information, there's more signal. There's more contrast resolution on a thicker slice. So when we put that together, the relationship then, we look at spatial resolution. A super thin slice is going to give us great spatial resolution. Super thin with a great matrix, right? We're going to have great spatial resolution. But that super thin slice with that high matrix, if I don't have enough mass, it's going to be super noisy, right? It's going to be mottled and noisy. So that would have a lower contrast resolution with the inappropriate technique. But if I take that thinner slice and I raise my dose to the patient, I use more mass, essentially. Now I've compensated. Now my thin slice can have good high contrast or good low contrast resolution as well. So you can have high spatial resolution and you can have high contrast resolution. But to do that, you have to increase dose. You have to add photons to that pot. So that's why we don't always scan at the thinnest slice possible, because we're increasing dose. Does that make sense?
That makes sense, but I have another question.
Let's go.
Okay, so contrast resolution in CT, it's still referring to like the shades of gray, right? Or no? Kind of.
No, I would kind of, but not, I wouldn't connect that dot back to X-ray. Because when we say contrast in X-ray, we're talking about the scale of contrast in the image. Contrast resolution is not that.
Okay.
Contrast resolution is our ability to see subtle differences.
Okay, so say you have like a high contrast resolution, you'd be able to tell the difference between like really similar densities.
Right, right. And CT inherently has, that's better in CT like than it is in like some of the other modalities, okay? But we do need to understand what it is and some of the things that affect it. So that's really all that is. So I wouldn't put that back to X-ray into X-ray contrast like that. I think that would confuse you. Did I answer you?
Yeah, that makes more sense.
Okay. Yeah, make it a separate idea in your mind if you can, you know. And then start to understand the trade-off. I was trying to find a document for you guys that like has like all the parameters and like if this goes up, then this goes down. Because I know it's out there somewhere. I've seen it, but I can't find it yet. I'll try to get that together for you, or I'll just make a chart. Okay, because that's going to be a good study guide for you, so you can understand how all these different little pieces relate to each other, kind of at a glance. So I think you got one of those for your X-ray review. If you haven't gotten it yet, you will. Did I clear that up for you, Leah?
Yeah.
Okay, I know it's a lot. Okay, like I know it's a lot to kind of because it's new and you're still learning X-ray. Um, so I want this to be as clear as it can be on this. This is really a first pass on this. Um, so I want it to be clear. I also want to extend to you guys when this class is over and you take your CT clinics, if you need to, this summer, um, so you can get your exams. I want to, when August comes, how much of this do you think you're going to remember right out the gate?
None.
Right. Because you're going to graduate X-ray and you're going to pass your registry for X-ray. And then you're going to go to CT clinics for 8 weeks. And hopefully you study in that time. But then what? Right? Then August comes and it's time to take your CT registry. And you're like, oh crap, I just took a 16-week course 8 weeks ago. So if you want help before you sit for your registry for CT, my battery's low, sorry. You guys still there? Yeah. If you want help and to do a study session or a couple, I've done this with students in the past. We go to a coffee shop or something and we sit down, and as long as, I guess as COVID is gone, which we should be all right, I hope by then, but we'll sit down and we'll go through some of the areas you're struggling with. Because during your CT clinics, you will take mock registries. Okay. So that's helpful. But for you guys, or Audrey, if she watches this, then I'll extend that to all of you. If you want some one-on-one study time with anything on CT, just hit me up. You guys know how to get a hold of me, so we can do that. Okay. Okay. Good.
Sounds great.
Okay. One more thing. Yeah, same. With any of these concepts, if you guys ever want to just talk to me, you can text me, we can do a phone call, or we can try to set these things up, and I'll try to get some materials together to kind of help with the concept. All right. So just let me know. Stay in contact with me. Obviously, Savannah, we work together, but Leah, same. Okay. Just reach out if you need something, and I'll do my best to help you.
I got Savannah to do that.
Okay. Hey, whatever works. Just make sure you get what you need. Okay. I want you guys to try to learn this material. I want to make sure it's going in a way that when you do go to review, that you're not starting from scratch. You don't want that. So spend the time trying to get it.
I do have a question.
What's up?
You never said anything, or if you did, I didn't catch it,
Okay.
about volume averaging.
Yeah, I can go into that. So
So is it basically the thicker the slice, you'll have more space to average out?
Right. And volume averaging is bad, right? Because it could make us miss a mass or something. There's this image of the abdomen with spatial resolution here.
So if that's the case, then why do you have better contrast resolution when the slice gets bigger? If more densities average together.
Well, because volume averaging or partial volume averaging is kind of like one of the categories under spatial resolution, not contrast resolution.
Okay.
Does that make sense?
Yeah.
Okay.
So it's like the pixels, like it averages the pixel color or whatever.
Yeah. Let me do this screen share again and see if I can't find that. This is so dumb.
That's a cute background you got there.
Thank you. Okay, so if we look at this image, so if we look at B has a small matrix, so they have large pixels, right? We're talking 1, 2, 6 by 6. So really big pixels. So if that pixel is where the liver is, this in the example B, if that pixel was right over those two, you might not even see anything in that pixel on the image, because this whole section is going to be averaged as one set of Hounsfield units. All right, so you're only going to get an average of the densities in that pixel. If we go over here and we double our matrix size, essentially, if we double our matrix size, now we can fit both of those in one pixel, and all this other information on the side, like if this was a square right here, right? All this other information on the side will get averaged as liver tissue, and these will look like masses. So that's how partial volume averaging works, okay? So you said it right, Leo, when you asked the question. It's gonna average everything contained in the pixel into the value of Hounsfield units for that pixel. Does that make sense?
Yeah.
Okay, so we want a large matrix, and as thin as we can get on the slices, depending on the dose we're trying to keep, to demonstrate everything with good fidelity. And fidelity means like how accurately is the structure being imaged represented on the picture, right? How true to life is it? If you go back to your book with the MTF, that function, and it talks about like how systems are like have like a limiting spatial resolution. We want systems that can show the body true to life, right? And then it's our job to make sure we have protocols set up as technologists that minimize dose while maximizing visibility. Okay. How'd that go for you? How'd that go in?
I'm good.
Okay.
I think I'm good.
Okay. Now, do you both have your content specifications printed yet?
No, they're on my computer.
No.
All right. Okay. Make sure you get them.
Danielle finally put them on the course shelf. So.
Okay. Okay. So make sure you have them. And when you go through and you look for these concepts of high and low contrast resolution, you'll see it's not going to be a massive part of the test, but you need to understand it. Okay. So just that the content specs will help you put all of these ideas in perspective. So, because you'll know how many questions they can even ask you about it. So it kind of gives you a bird's eye view of what's really on your test. All right, any more questions?
I have a totally random question that has nothing to do with CT.
Let's go. What is it?
Do you know if April checks her email on the weekends?
I don't. I don't know. Yeah, I'm sure. I mean, because it goes to her phone. Whether or not she feels obligated to return your email until Monday, she may be busy.
Yeah, she hasn't answered.
Did you already
Why?
email her?
I emailed her yesterday.
Okay.
Am I forgetting something to do?
No. I think you're. I think you're. I don't know. All right, guys. Do you have any other questions?
No.
Okay.
No.
Well, it's good to talk to you, even though I didn't see your face, Leah.
She had it on at the very, very beginning before you joined.
Oh, there you go, girl. All right. Well, you guys have a good night. Hit me up if you need anything. Savannah, I'll see you bright and early.
I'll see you tomorrow.
All right. Bye.
Unless it just snows a bunch, then I'm not coming.